Welcome to today's lesson on measuring segments. Our objective today is to find and compare the lengths of segments. We're going to do this using some important postulates and definitions from geometry. We're going to start with postulate 1.5, the ruler postulate. It says every point on a line can be paired with a number on the real number line. The distance between 2 points is the absolute value of the difference between the numbers. Basically, it's just saying if you had a line, that for each point on this line, you could basically give it a number just as if you were lining it up against the number line. So we might have a line, and we could call this point right here 2, and we could call this point down here maybe -5, knowing that 0 would be somewhere in the middle. If we want to find the distance between 2 points, we can always subtract these two numbers. If we do larger minus smaller, we'll always get a positive answer. 2 minus -5 is really 2 plus 5, or 7. If, however, for some reason we were taking the smaller number and subtracting the larger number, we would get a negative. Since distance can't be negative, we would say that no matter what, it's the absolute value of the difference. We can see this makes sense in this problem because 0 would be somewhere right here, and it's 2 units to 0, and then 5 more units, which is a total of 7 units. So let's look at an example here. Notice this says what is AB, and there is no symbol on top of this. That indicates that this is not a line or a ray or a segment. In geometry, if there is no symbol, this simply means what is the distance from A to B. Now on this one we can look at this and see that it's 1, 2 units from A to B. If, however, this was a little more difficult problem, remember we could subtract. The larger number is -2 minus the smaller number -4, which again this would be -2 plus 4, which would be +2. What is the distance from A to C? If we count 1, 2, 3, 4, 5, 6, 7 units. So the distance from A to C is 7 units. Again, the larger number is 3 minus the smaller number, -4. That would really be 3 plus 4, which is 7. And last, what is the distance from D to A? Well, we've already counted that this is 7 units from A to C, and it's just 2 more units, so that one would be 9 units. An important definition in geometry, one which you've probably heard before, is the word congruent. Congruent simply means having the same measure. The symbol for congruent in geometry is an equal sign with a little wave over the top. Name 2 congruent segments in the picture above. Now notice here we could say segment AB is congruent to segment CD because both of those segments are 2 units in length. But let's find another set of segments that's congruent. If I notice that this is 2 units and this is 2 units also, another segment is, I could say, from A to C, which was 7 units, and from B to D, which would also be 7 units. Those are congruent. So segment AC is congruent to segment BD. Don't forget to put your symbols over your segments. Our next postulate, postulate 1.6, is called the segment addition postulate. It says if 3 points A, B, and C are collinear, and B is between A and C, then the distance from A to B plus the distance from B to C is equal to the distance from A to C. Let's look at this in a drawing. This simply says we're going to have 3 points all on the same line. That's what collinear means. And it says B is between A and C, so we're going to put B in the middle. The distance from A to B added with the distance from B to C would equal the total distance from A to C. Basically, the two smaller segments can be added to equal the length of the longer segment. Let's look at some examples of how to use the segment addition postulate. Number 1 says, answer each of the following using the diagram provided. Letter A, write the segment addition postulate for points M, N, and P. All this means is to take what we learned and simply use M, N, and P instead of A, B, and C to write our segment addition postulate. So the distance from M to N plus the distance from N to P is equal to the distance from M to P. Now we notice that it says MN is 3 and NP is 8. Find MP. Well, we know that if we add the two smaller segments, that's going to equal MP. So MP is 11. Let's look at another example. Answer each of the following using the diagram provided. A, write the segment addition postulate for points R, S, and T. So this is the same thing we did on the last example. So RS is one of the smaller segments, plus ST would equal RT. Letter B says, what is the distance from R to S? Now we can look at this and we can see that R is at -4 and S is at +2. Using what we learned from the ruler postulate, we can subtract the two numbers, and 2 minus -4, which is really 2 plus 4, is 6. So it is 6 units from R to S. From S to T would be 10 take away 2, or it's 8 units from S to T. So the distance from R to T is simply those two segment lengths added together. So 6 plus 8 equals 14. So it is 14 units from R to T. Now let's look at how we can apply the segment addition postulate when we have variables involved. In problem 3, the distance from E to G is 59, and we need to find the length of EF and the length of FG. If I notice, the distance from E to G is simply the length of the two smaller segments put together. So if I use the segment addition postulate, I know that EF and FG can be added together to equal EG. Since EF is 8x minus 14 and FG is 4x plus 1, I can add those two segment lengths together to equal the total length of 59. And now I have an equation which I can solve. I will start by combining like terms. 12x and -14 plus 1 is -13. So 12x minus 13 equals 59. I need to add 13 to both sides. And 12x equals 72. I divide both sides by 12 to find out that x equals 6. Notice, however, that I'm not done in this problem. I was not asked just to find x, I'm asked to find the distance from E to F. I know that the distance from E to F is 8 times x minus 14, or 8 times 6, which is 48, and 48 minus 14 is 34. So from E to F is 34. Now I need to find FG. FG is 4x plus 1, or 4 times 6 plus 1, which is 25. So FG equals 25. I can tell that this answer makes sense because when I add 34 and 25 together, I get a total of 59, which is the length from E to G. Now let's look at another example together. If MN is 5 and MP is 13, then find NP. Notice this is still the segment addition postulate because I know that 5 plus whatever NP is will equal the total, or 13. Since I already know the total, I can go backwards and I can subtract 5, and NP is simply 13 take away 5, or 8. There are some other definitions that can help us when we're finding the length of segments. First, we have midpoint. A midpoint is exactly what it sounds like. It's a point that's in the middle. Or in other words, a point that divides a segment into two congruent segments. Notice these little markings here. These are showing me that these two segments are the same length because they're marked the same. So the distance from A to B and the distance from B to C are the same. This means that in this case, B is the midpoint, or the point in the middle. Another important definition is the word bisect. We know that the prefix bi means two, so think of this as two sections. Bisect means to cut something into two equal pieces, or in other words, you have two sections that are equal. Notice in this picture, MT and TD are congruent because they're given the same mark. This would make point T the midpoint. It would also mean that point T bisects segment MD. In other words, point T cuts segment MD in half. I could also say that segment IP bisects segment MD. This is another way of saying that segment MD has been cut into two equal parts. Notice, a midpoint must be a point, but when we talk about bisecting, a point can be a bisector, T bisects MD, a segment can be a bisector, segment IP bisects segment MD. We could also have a ray or a line that is a bisector. In this example, notice that it says U is the midpoint of TV. If U is the midpoint, we know that U cuts TV into two segments that are congruent. So notice I'm giving them congruent markings. If we want to find x, we can set up an equation saying that TU, or 8x plus 11, is equal to UV, 12x minus 1. I can now solve this for x. First, I'm going to bring all x's to one side by subtracting 8x. I now have 11 equals 4x minus 1. I add 1 to both sides, giving me 12 equals 4x, and I divide by 4, and x equals 3. Now we need to find TU, UV, and TV. We know that TU is 8 times x, or 8 times 3, plus 11. So TU is 24 plus 11, which is 35. UV is 12 times x, or 12 times 3, minus 1. 12 times 3 is 36, and 36 minus 1 is 35. Notice we know our answer makes sense because we know that TU and UV are supposed to be the same length. And in order to find TV, we can simply add 35 plus 35, and so the total length is 70. So in this lesson, we've learned a couple of things that can help us to find lengths of segments. We've talked about the segment addition postulate, the midpoint, and bisect. Thank you for watching today's lesson.